In this chapter, we're going to start our work with solving quadratic equations, or continue our work with solving quadratic equations. We have a theorem here that we're going to use, which is written like this. It says, if the square of a is equal to a number b, then a must be either the positive square root of b, or a must be the negative square root of b. We have a shorthand way that we write that as a equals plus or minus the square root of b, meaning the positive or the negative square root of b. So if a squared is equal to b, then a itself must be either the positive square root of b, or a is the negative square root of b. Now when we solve equations using this property, it will look like this. A squared is equal to x squared is equal to 9. That means that x is plus or minus the square root of 9, which is plus or minus 3, because the square root of 9 is 3. That tells me that one solution is positive 3 to this equation, and the other solution is negative 3 to this equation. So x squared equal 9, you can see that if I square 3, I get 9, and if I square the quantity negative 3, I also get 9. So these do, in fact, give me the two solutions to that equation. So we want to use this property to solve a variety of equations. Here's our first one. Y squared is equal to 8. I'll apply this new theorem that I have and write y is equal to plus or minus the square root of 8. Now all I have to do is put this radical in simplified form. Y is equal to plus or minus 8 is 4 times 2. The square root of 4 is 2, so I get 2 square root 2. So y equals plus or minus 2 square root 2. Those are the two solutions to my equation y squared is equal to 8. So you can see that this is a nice simple theorem to apply. If the square of a number is equal to another number, then that original number is either the positive or the negative square root of this number on the right side. Let's look at a little more complicated problem. 3a squared equals 54. I want to solve this equation for a. So what I'm going to do is first divide both sides by 3. So I'll end up with a squared equals 54 divided by 3, which is what? 18. That's right. So a squared is equal to 18. Now I'll apply my new theorem and write a as either the positive or the negative square root of 18. And since 18 is the perfect square, contains the perfect square 9, that is, it's 9 times 2, I get plus or minus 3 square root 2 for my two solutions to that equation. So 3a squared equal 54 has two solutions, plus 3 square root 2 and minus 3 square root 2. Here's our next problem. A minus 5 squared, quantity squared, equals 75. Okay, it doesn't matter that this is a binomial here. What matters is that it's a square. So the square of this number is equal to 75. That means that this number itself, a minus 5, is plus or minus the square root of 75. So I apply my property to this expression just like I have to the ones previous to this. Now, I can add 5 to both sides of this equation and get a is equal to 5 plus or minus the square root of 75. Well, let's see, 75 is 25 times 3, so that 25 will come out as a 5 square root 3. So I get two solutions, 5 plus 5 square root 3 and 5 minus 5 square root 3 for the solutions to that equation. So a minus 5 quantity squared equals 75. I take the square root of both sides of the equation, or I write a minus 5 as plus or minus the square root of 75. That simplifies down to 5 square root 3. Over here I add 5 to both sides and I get this expression, 5 plus or minus 5 times the square root of 3. Now remember, this is shorthand notation for 5 plus 5 square root 3 or 5 minus 5 square root 3. I combine these two expressions together with this shorthand notation using this plus or minus symbol. Here's another problem. 4a minus 5 quantity squared equals 36. So I have the square of 4a minus 5 equal to 36. By my theorem, that means that 4a minus 5 is equal to plus or minus the square root of 36, which is plus or minus 6, because 36 is a perfect square. So plus or minus the square root of 36 is plus or minus 6. Now I'm going to add 5 to both sides of this equation, and I have 4a is equal to 5 plus or minus 6. Now I'll divide both sides by 4, and I have a is equal to 5 plus or minus 6, all divided by 4. Now that will give me two solutions. One where I use the plus sign, 5 plus 6 divided by 4. 5 plus 6 is 11 divided by 4. And when I use the minus sign, 5 minus 6 divided by 4. Negative 2 over 4. Whoops, negative 1 over 4. Thank you. I was almost going to reduce that to lowest terms. So 5 minus 6 is negative 1. So I get negative 1/4. So here are my two solutions, negative 1/4 and positive 11/4. So two solutions to this equation, and I've found them by using this property that allows me to take a square like this and rewrite it as plus or minus the square root of what's on the right side of the equation. Our next problem. 3x plus 6 quantity squared equals 45. So I'm going to use my theorem and say if 3x plus 6 squared is 45, then 3x plus 6 itself is plus or minus the square root of 45. 45 then is 9 times 5, so I see I can write that as 3 square root 5. So I get 3x plus 6 is equal to plus or minus 3 square root 5 when I write square root 45 in simplified form as 3 square root 5. Now I'll add negative 6 to both sides. 3x is equal to negative 6 plus or minus 3 square root 5. Divide both sides by 3 and I get x equals negative 6 plus or minus 3 square root 5 all divided by 3. So here I have two solutions. One is negative 6 plus 3 square root 5 over 3, and the other is negative 6 minus 3 square root 5 over 3. But notice that 3 divides each of the terms in the numerator, or the numerator has a factor of 3 common to both terms, and that should divide out with this 3. So I'm going to take one more step here and factor a 3 from the numerator. When I do, what's left is negative 2 plus or minus square root 5. That's all divided by 3. Those 3's will divide out, and I'm going to be left with x equal negative 2 plus or minus the square root of 5. So I end up with two solutions. One is negative 2 plus square root 5, and the other is negative 2 minus square root 5. So in this situation, you always want to reduce to lowest terms if you see that there's a factor common to the numerator and denominator. It will just make your solutions a little easier to look at. Our next problem involves some fractions. I'll write x plus 1/2 as plus or minus square root of 7/4. Now I'll use my property of radicals to write this as square root 7 over square root 4, which is plus or minus square root 7 over 2, because the square root of 4 is 2. So this is what I have. X plus 1/2 is equal to plus or minus square root 7 over 2. Now I'll add negative 1/2 to both sides. Negative 1/2 plus or minus square root 7 over 2. And if we want, since these fractions have the same denominator, we can simplify even a little bit more. Negative 1 plus or minus square root 7 all divided by 2. So if I want to write it that way, as a fraction with just one denominator here, I can do that. So even if I have fractions in here, as long as this has the form a squared equals b, then a itself is plus or minus the square root of b. Sometimes we have radicals we can simplify, sometimes we don't. In any case, we want to carry it down to the simplest form for our two solutions.